Hello, in this video we're going to write a program that computes the great circle distance, and we're going to use Earth as an example. And in writing this program we're going to use Java's built-in methods for mathematical operations. So, what is the great circle distance? Well, if you imagine a sphere, here's a sphere, and you want to calculate the distance between 2 points on this sphere. So here's point 1 and here's point 2. Now you could use your regular trigonometric functions to calculate a distance between these 2 points. However, it would be this distance here, the straight line distance, and it would. But suppose this was the Earth and you want to calculate how far you'd actually have to travel to get from one point to the other. What you're actually looking for is the distance along the surface of the sphere, and that is what the great circle distance tells us. So, over in Eclipse, let's get started. I've already created a new Java project called Great Circle Distance, and to this we'll add a class, also called Great Circle Distance. The first thing we'll do inside our class is to import scanner, because we'll be reading from the console. So import java.util.scanner. Now inside our class we will create our main method, and the first thing we'll do inside our main method is to create our scanner object for reading from the console. So scanner input equals new scanner, and we are reading from system.in. Next up, we'll print out some instructions for the user. So system.out.print enter point 1 latitude and longitude in degrees. And then we'll read in the point that they've specified, and we're going to store this in 2 double variables. So double x1 equals input dot next double, and we do the same thing with a variable called y1. Next up, we'll read in the second point. So what I'm going to do is copy and paste these 3 lines of code, change it to print out point 2, and change our variable names to indicate that we're storing our second point. With that, that's all the information we need. We just need the coordinates of the 2 points. So we can go ahead and calculate the great circle distance between these 2 points. And the way we do it is like this. We're going to have a double called d, which will store our distance. And then we have a mathematical formula. Now you can look this up on the internet. It's no big secret, but I'm just going to type it in to keep the video short. The first thing we need is the radius of the sphere that we're dealing with. Now I said at the start of this video, we're going to use Earth as an example. And I happen to know that the radius of Earth is 6,371 kilometers, 0.01. Close enough for our needs anyway. Next up, we're going to use some of Java's mathematical operations. And most of these are stored inside the math class. So if I go math dot, we'll get a whole list, a big list of all these different mathematical functions that are available to us in Java. The one we're looking for right now is ACOS. Now, inside here, we're going to have the rest of our formula. It's all going to be contained inside a call to ACOS. So, first thing we need is the sine function. So math.sine. Now, all the trigonometric functions like sine, cosine, and tan in Java take radians as their units for an angle. Now, we've asked the user to enter their coordinates in degrees, so we need to convert from degrees to radians. And luckily, Java comes to the rescue again with a method inside math.toRadians. So what we're going to put in here is the variable x1. We're going to come out of 2 layers of parentheses now, so we're still inside our ACOS method, and we're going to multiply this by math.sine, again convert to radians, and we'll use x2, and we'll come out down to here, and I'll go down onto a new line to give us a bit more room. So again, we still have our closing paren for the acos call, and inside here we're going to add math.cos cosine. Again, convert to radians, math.to_radians, and this time we're going to use x1. Again, come out 2 levels of parentheses and multiply this by math.cosine, math.to_radians x2, and then again come out 2 levels of parentheses. We're going to multiply this by math.cosine, math.to_radians, and this time we're going to use y1 minus y2, and we can get out of our acos call now, because that's the end, that's all we need. Put our semicolon on the end, and that is how we calculate the great circle distance. Now again, you can look this up on the internet and get a nice formula for this, but trust me, that's what it is. So all that's left is to print this out to the user. System.out.println, the distance between the 2 points is, print out the distance and add our units. Remember that our initial radius, the 6,371, was kilometers, therefore our final answer is also going to be in kilometers, and that is all we need for this program. So I'll save this and then we can run it. Now we need 2 points, and I've got a couple of points here just to make things a bit easier. So let's start with point 1 being Adelaide in South Australia, the city where I am right now. I happen to know that the coordinates for Adelaide are roughly minus 34.929 and 138.601. So, our second point, let's use Sydney, another big city in Australia, and the latitude and longitude for Sydney is minus 33.8599, let's just keep it simple, 859, and 151.211. Press enter and we get the distance as being 1,162 kilometers, 0.34, roughly about that. So, are we correct? Well, let's just have a quick look at what the internet says. Adelaide to Sydney inside Google Maps, and we get 1,375 kilometers, but you have to remember that's taking roads. We calculated the straight line distance along the surface of the Earth to be 1,162, which I think is probably correct. So with that, that's it for this video. We've used some of Java's built-in mathematical operations inside the math class to calculate the great circle distance between 2 points on Earth. Thanks a lot.